Okay, we will go through some important points in the class 12 chemistry chapter 10, HaloAlkanes and HaloArenes. Okay, the replacement of the hydrogen atoms to an aliphatic or aromatic hydrocarbon by halogen atoms results in the formation of the alkyl halide, that is haloalkane, and aryl halide, that is haloarene, respectively. Haloalkanes contain halogen atoms attached to the sp3 hybridized carbon atom of the alkyl group, whereas haloarenes attached to the sp2. So arenes attached to sp2 hybridized carbon atoms of the aryl group. Okay. So we can haloalkanes depending on the number of halogen atom, it can be classified mono, di and polyhalogen. Okay, this alkane, this thing and all is sp3 hybridized, whereas this dihaloarene, trihaloarene, these things are sp2 hybridized. So here haloalkane means Rx. R is alkyl group, X halogen atom. Okay, this is the general formula CnH2n plus 1x. So if you put n equal to 2, C2H5x. They are further classified the primary, secondary and tertiary according to the nature of the carbonate. Okay, it is connected to the primary carbon atom and primary halide. Secondary carbon atom means in secondary halide. Primary halide is represented as 1 degree alkyl halide, secondary 2 degree tertiary. See here, this halogen atom is connected to the one carbon atoms, which is connected to the only one alkyl group, but here this carbon atom is connected to the 2 alkyl group, and this carbon atom is connected to 3, that is why tertiary. Aliphatic halides, they are the compounds in which halogen atom is bonded to one sp3 hybridized. Okay, atom adjacent to the carbon-carbon double bond. This is sp3. Benzylic, this is sp3. They are the compound in which halogen atom is connected to an sp3 hybridized carbon atom attached to an aromatic ring. Okay, they are attached to the aromatic ring. This is vinyl halide. They are the compounds in the halogen atom is bonded to the sp2. Okay, sp2 hybridized carbon atom of the carbon-carbon double bond. So here this aryl is directly attached to the benzene ring. Halogen atom is directly attached to the sp2 hybridized carbon atom of the aromatic ring. For dihalogen derivative, the prefixes OMV, ortho, meta, para are used in common system, but in IUPAC system, as you have learned in class 11, unit 12, are used 1, 2, 1, 3, 1, 4 are used. This is the IUPAC name and this is the common name. Okay. The dihaloalkanes having the same type of halogen atoms are named as alkylidene, alkylidene. This is the same dihalides in which both halogen atoms are present in the same carbon atom. Okay. See here, this both Cl atoms are connected to the same carbon atom, whereas here these two Cl atoms are connected to the adjacent carbon atoms. Adjacent carbon atom is same carbon atom. This is called Zim dihalide. This is trihalide. Okay. Common and IUPAC names. Okay, here primary because this halogen atom is connected to a carbon atom which is connected to only one carbon atom. This is secondary because this carbon atom is connected to the carbon atom which is connected to the two carbon atom, left side one, right side one. Okay, tertiary attached to the three carbon atoms. Halogen atoms are more electronegative than carbon. In this CX, C is partial positive and the X, that is halogen atom, is partial negative. In the halogen series, fluorine is the smallest, iodine is the largest. As we go from the group in the periodic, the size of the halogen increases. Fluorine atom is the smallest, iodine atom is the largest. Okay. Alkyl are best prepared from alcohol which are easily accessible. The phosphorus these things you can go through. See here, this is important. The reaction of the primary and the secondary alcohols with HCl require the catalyst zinc chloride. For the primary and secondary alcohol with HCl requires catalyst zinc chloride, but tertiary alcohol, the reaction is carried simply by shaking the alcohol with constant. Okay, tertiary alcohol, they don't need the catalyst. The order of the reactivity alcohols is order of the reactivity of the alcohols are tertiary greater than secondary greater than the primary. This is how the alkenes or HaloAlkanes are prepared, these reactions. The above method are not applicable for prepare only for the alkyl halides. These RL halides are not prepared with those because the carbon oxygen bond in phenols have the partial double bond character and is difficult to break. Okay, from hydrocarbons, how HaloAlkanes by free radical halogenation. Separate sp compound consequently to yield anything. Okay, from alkenes, an alkyl is converted into alkyl halide by reaction with hydrogen chloride, hydrogen bromide and hydrogen iodide. Hydrogen chloride, bromide and iodide. This the yield is according to Markovnikov's rule. Okay. So the bond with carbon with less number of hydrogen bond is combined with this iodine atom here. So here this is the major product and this is the minor product. Major means C, carbon with less number of hydrogen atoms. So iodine will combine, will form the major product here. So here this is the less number of hydrogen atoms. Halogen exchange. This is a Finkelstein reaction. Halogen exchange reaction. Rx plus NaI, RiNaX. Synthesis of alkyl fluoride is best accomplished by heating an alkyl chloride bromide in the presence of the metallic profile, such as these things. Preparation of the HaloArenes by electrophilic substitution. Aryl chloride bromide are easily prepared by electrophilic substitution reactions with the chlorine bromine respectively in the presence of the Lewis acid as catalyst. Lewis acid like iron 3 chloride. This is called toluene. Okay. But to prepare iodide, we need a oxidizing agent. That is was given here. Orthomer isomer can easily be separated due to the large difference in melting points. Reaction with iodine are reversible in nature and require the presence of the oxidizing agent. Okay, to oxidize HI formed during the iodination. Fluoro compounds are not prepared by due to the high reactivity of the fluorine. This is Sandmeyer's reaction. Okay, this is Sandmeyer's reaction. In a primary aromatic amine, this is aromatic amine reacts with this. So Melting and boiling point. The intermolecular forces of attraction, dipole and van der Waals are stronger in halogen derivatives. That is why the boiling points of the chloride, bromide and iodides are considerably higher than that of the hydrocarbons of comparable molecular mass. If the molecular mass is same, hydrocarbons will have lesser boiling point than the halides, halogen derivatives. Halogen derivatives will have the more boiling point than the hydrocarbon derivatives. So for the same alkyl group, the boiling point of the alkyl halides decrease. Like iodine will have the more than bromine, than the chlorine, than the fluorine. So here iodine is the iodine derivative, they have the more boiling point. The boiling point isomeric alkanes decrease with increase in branching. If you branch increases, then boiling point decreases for the alkanes. The para isomers are high melting as compared to the ortho and meta isomers. The para isomers are high melting point as compared to the ortho and meta isomers due to the symmetry of the para isomers that fits the crystal lattice better as compared to ortho or meta isomers. So para isomers have more boiling point. So the density increases with increasing number of the carbon atoms, halogen atoms and atomic mass. Okay, when you increase number of carbon atoms, halogen atoms and atomic mass, the density increases. See here, iodine have more density than bromine than chlorine. So more halogen atoms here attached, more density. Here see 4 halogen atom, 3 and 2. So the 4 halogen atom have more density. Solubility. All alkenes are very slightly soluble in water. In order to dissolve all alkenes in water, energy is required to overcome the attractions between the all alkene molecules and break the hydrogen bonds between the water molecules. Less energy is released. See, this nucleophile means nuclear lovers. That means nucleophiles is negatively charged. They are loving nucleus. Nucleus is positively charged, so nucleophile should be negatively charged. It is electron rich. Nucleophile substitution reaction. This is the general RX Na minus this. Groups like cyanides and nitrate possesses 2 nucleophilic centers. They are called ambident nucleophiles. You have SN2 reaction. This rate depends on concentration of both the reaction SN2. So this rate of this reaction depends on the concentration of both the reactions, both the reactants. Okay, this molecular represented means straight line is in plane, solid line is coming out of the plane, and dashed means going into the plane, going down the plane. Okay, solid coming out of the plane. Incoming outgoing. So the SN2 reaction is a single step reaction. These two occurs in a single step, no intermediate is formed. SN2 reaction is a single step reaction. It depends on the concentration of both the reactants. Okay, you see. So simple alkyl halides, methyl halides react most rapidly in SN2 reaction because they are only 3 small hydrogen atoms. Tertiary alkyls are the least reactive. So SN2 primary alkyl halides is more reactive than the secondary, than the tertiary. Tertiary is less reactive in SN2. This is the order of reactivity. Primary halide greater than secondary halide and tertiary halide for the SN2. For SN1, this rate of the reaction is depends on only one reactant. Okay, the rate of the reaction depends on the only one reactant, and this molecularity is 1. Okay, this SN1 reaction occurs in 2 steps. Intermediate carbocation is formed here in this. So there are 2 steps in SN1 reaction, and the concentration of this reaction depends on the concentration of only one reactant. Okay, step 1 is slowest and reversible. Rate of the reaction depends only on the concentration of the alkyl, not on the concentration of the hydroxy ion. So the reactivity of here it is ulta. Tertiary alkyl halide is undergo SN1 reaction very fast because of the high stability of the tertiary carbocations. So this is how the SN2 means tertiary less reactive, secondary more reactive, primary is more reactive than the other. But SN1 reaction opposite. Tertiary is more reactive than the primary thing. The carbocation was stabilized through resonance. For a given alkyl group, the reactions of the halide Rx follows the same order for both the mechanism. Reactivity of the Ri is greater than the bromide, greater than the chlorine and fluorine. So iodine will have the more reactivity. Chiral versus achiral sterility. Okay, the objects which are non-superimposable with their mirror image like a pair of hands are called, they are the non-superimposable. These are the chiral object. This is non-chiral. See here, these two are called an A and B are enantiomers. They are non-superimposable, and here this is a achiral because this A and C are superimposable. This is achiral. A and B are not superimposable, but after 180 degree, the C and A are superimposable. So they are called achiral molecule. But here D and D are enantiomer, that is non-superimposable. Here the rotated image, that is chiral. So this is different groups attached to the O difference. So okay, he rotated 180 degree, and this F is non-superimposable with D. Here so this is chiral. Okay, D and E are enantiomers, D and F are chiral. But here A and B are enantiomers and A and C are achiral. Stereoism each other of the non-superimposable image are called enantiomers. Okay, the examples above figures. A mixture containing two enantiomers is equal proportions will have a zero optical rotation. Rotation due to the isomer will be cancelled with rotation. Such a mixture is known as racemic mixture. The location of the alpha beta carbon in a molecule. Carbon on which halogen atoms is directly attached is called the alpha, and the carbon atom adjacent to this is called beta. So here is the example alpha, beta, gamma. Okay, when a HaloAlkanes with a beta hydrogen atom is heated with alcoholic solution of the potassium hydroxide, there is a elimination of the hydrogen atom from beta carbon. Okay, beta carbon, and the halogen atom from a alpha carbon atom. This is the elimination reaction. B is the base and X is leaving group. As a result, the alkene is formed as a product. Since the beta hydrogen atom is involved in the elimination, it's called beta elimination. Sites are sites of reaction. Okay. What is this reaction? Dehydrohalogenation reactions. It is called dehydrohalogenation. The preferred product is the alkene which has the greater number of alkyl groups. Okay, the preferred product is that alkene which has the greater number of alkyl groups attached to the doubly bonded carbon atoms. Okay, so so the greater number of alkyl group, this is the minor product and this is the major product. So this has the greater number of the alkyl group attached to the doubly bonded carbon atoms. So here this is double bonded and this side is the greater number of alkyl groups. So here you see this side is less. This is the minor product. This is 19% only. This is 81%. Difference between elimination and the substitution. Okay, primary alkyl halide undergo SN2 or tertiary SN1. That is already we have seen it. Grignard reagents are highly reactive and react with any source of proton to give hydrocarbons. Even water alcohols, amines are sufficiently acidic to convert them into the corresponding hydrocarbons. It is therefore necessary to avoid even traces of moisture from Grignard reagent. This is the Woods reaction. Alkyl halides react with sodium in dry ether to give hydrocarbons. Woods reaction. If you have more S character means there is more electronegative. So here more S character, that is sp2 hybridized carbon with greater S character is more electronegative than the sp3. HaloArenes are less reactive than the haloalkanes towards nucleophilic substitution reactions. HaloArenes are less reactive than alkane towards nucleophilic substitution reactions. The presence of the electron withdrawing group nitro group at the ortho and the para position increases the reactivity of the HaloArenes. Presence of the electron withdrawing group, that is nitro group, at ortho and para position increases the reactivity of the ortho and para position, increases the reactivity of the HaloArenes. The effect pronounced when nitro group introduced in the ortho and para positions observed by the presence of the electron withdrawing group, the meta position. I shown the presence of the nitro group at the ortho para position withdraws the electron density from the benzene ring and thus facilitates the attack of the nucleophile on haloarene. Okay. The carbanion thus formed is stabilized through resonance. The negative charge appeared at the ortho para position with respect to the halogen substituent is substituted by the nitro group. While in case of the meta-nitrobenzene, none of the resonating structures bear the negative charge on the carbon atom bearing nitric. Therefore, the presence of the nitro group at meta position does not stabilize the negative charge, and no effect of the reactivity observed with the nitro group at the meta position. Electrophilic substitution reactions. Ortho-para directing influence of the halogen atom can easily be understood. Due to resonance, the electron density increases more at the ortho and para positions than at the meta position. Due to resonance, the electron density at the ortho para position increases than the meta position. Woods fatigue reaction. Okay, a mixture of an alkyl halide and aryl halide gives alkyl arene when treated with sodium the dry ether. This is Woods fatigue reaction. Okay, Woods reaction is different from the Woods fatigue reaction. Carbon compounds containing more than one halogen atoms are referred as polyhalogen compounds. Trihaloromethane chloroform. This is iodoform. Iodoform is anesthetic. Schwarz reaction. What is Schwarz reaction? The use of DTT. Problems related to the extensive use of DTT. What are the problems of use of the DTT? The DTT is banned in the United States. Okay, summary. The number of polyhalogen compounds, example dichloromethane, chloroform, iodoform, DTT have many industrial applications. However, these compounds cannot be easily decomposed and even cause depletion of ozone layer and are proving the environmental hazard. So DTT is proving to be environmental hazard. Okay.